Okay, so we started off finding our center, whatever's with our x and our y. That's at 0, 0, so I'm going to go to the middle and put our point. This is a hyperbola and not an ellipse. Okay, look at that equation. It looks very, very similar to an ellipse, but it's not. What's the one thing that's different with this and what we graphed in bell work? A minus sign. That's the only thing that's different. Okay, and because of that, this picture is going to be very similar to graph. Okay, so in between here, there's a minus sign instead of a plus sign within our ellipse. Okay, so keep that in mind here. But let's go ahead and do the same thing we always do. We're going to square root the number underneath our x squared. It's 9. So which way are we going to go 9? Or which way are we going to go 3? Because it's the square root of 9. Left and right, because it's underneath our x. So from our middle, 1, 2, 3, put a dot. 1, 2, 3, put a dot. Okay, great. From there, we're going to take our y. We're going to square root what is underneath it. It's 4. So we square root it, we get 2. So since it's underneath our y, we're going to go up 2 and down 2. Before we would make an ellipse, that's not what we're going to do here. We are going to make a rectangle instead. So when it's an ellipse, we're going to make a rectangle using these 4 dots. So I'm going to connect these dots in a rectangular shape. Okay, so instead of doing an ellipse shape, we're going to make it a box there. From there, the next thing we're going to do is add an asymptote line. Okay, what we're going to do is I call X the box here. We're going to X it. Okay, so what we're going to do is we're going to draw lines, and if you got a straight edge, use it. Okay, I want it to be fairly accurate. I'm going to draw lines from one corner of this box across to the other corner. Okay, both directions. So from that corner to that corner, and from this corner to this corner. Okay, trying to hit that corner. Okay, do the best you can. So if you got to just sketch, do it. You don't have to make it dashed. If you want to make it a solid line, I'm not going to count that off. Okay, but you're trying to do the best you can there. Okay, what ends up happening, I want it somewhat accurate because eventually kids get tired and they start giving me X's like this in your box, and that's not good. Don't do that. Okay, try to reach the corner to corner here. Good to that point. Last thing we're going to do is actually make our shape. All right, so again, it just matters which letter comes first. We're graphing a hyperbola. We got to look, what's that first thing that's being squared? Which one's positive and which one's going to be minus? So in this case, x squared is first. If you have a hyperbola with x squared first, your parabolas are going to go left and right. Okay? Think about what's happening here. This looks very similar to an ellipse. So think about this shape. There's our ellipse, correct? The minus sign, basically what we're doing is we are breaking this thing and making it go outwards instead of an inward ellipse. That's what the minus sign is doing to it. It's kind of splitting it in half. Here's how we're going to graph it. Okay, so since it's an x squared first, it's going to open left and right. It's going to look like this. So we're going to use this point right here and this point right here to draw our parabolas. These green lines are asymptote lines. So asymptote lines, remember, we get really, really close to them, but we don't touch. Okay, so using this dot right here, I'm going to go up this way, get really, really close, but don't touch. Go this way, oh, that was bad. That touched a lot. Let's try again. Really, really close, but not touch. Go in that direction. Same thing over here. Really close, but not touch. Really close, but not touch. There's our shape. Technically, if I type this into my Desmos calculator, I could pull it up. All you would see are the blue lines. Everything else is there to help you. Without them, you can't graph them very well. But those blue lines are necessary, or the blue lines is what it really is. Everything else is necessary to help me get to that point. Question so far? All we got left is labeling. So before with ellipse, we had major axis and minor axis. With this one, we've got the transverse axis and the conjugate axis. Let's go English class on you for a minute. The prefix trans, T-R-A-N-S. Anybody know what that prefix trans means? Say it again. It means across. You ever heard of a transatlantic flight? If you have, a transatlantic flight means a flight that goes across the Atlantic Ocean. Okay? That's what trans is. Okay, when we see this trans right here, this means across. And for us, it's the axis that goes across from one parabola to the other. The transverse axis connects your two parabolas. So that would be this axis right here. That's our transverse axis. Okay? So my transverse axis goes from 3, 0 to negative 3, 0. The conjugate axis is the lesser of the two. It's not as important, so it's the other one. The transverse connects the two parabolas. The conjugate would be the horizontal axis in this, or the vertical axis in this case. 0, 2, and 0, negative 2. Let's skip foci. We'll come back to that in a second. Let's talk about slope. So in 7th grade, when you first learned slope up until your last math class ever, you're going to talk about slope. It's all the time. We haven't talked about it in a while. What in your brain, when you hear the word slope, what is that little saying that we think always goes when we talk about slope? So I always hear y equals mx plus b. Y equals mx plus b is slope form. That's how you graph a line. But when we're just talking about slope, that's how slanted is your line. It's a bad way of saying it. And the way we get that is by using rise over, whatever I'm spelling here, rise over run. Okay, so I want to count how much did I go up and how much did I go over. The easiest way to do that is to start in the middle of my box and count to my top right-hand corner. How much did I go up and how much did I get over to get there? So I count up, 1, 2, and I go over 1, 2, 3. So my slope is 2/3. One of my line goes up 2 over 3. What's my other line do? Down 2 over 3. So my slope is plus and minus 2/3. I've got one that goes up and one that goes down. We're almost there. We got one last thing here. We got to do foci. Remember foci, when we talk about ellipse, it was big number minus little number equals c squared. It's going to look very similar for foci on this one. Here, I don't really care which number's big and which number's little. They're going to equal c squared, but the last one was minus. Now it's going to be plus. It's always the opposite of whatever sign's in the middle. So since it was a minus sign, it's going to be a plus when I do my foci equation. So I'm taking my two numbers on bottom, 9 and 4. I'm going to add them together. It gets me 13. What do you think I need to do with that 13? Square root 13. It gets me 3.6. 3.6. Now think about this. I am making foci, which is the plural for focus. Which direction am I going to go 3.6 to mark my foci? The answer is left and right. Andy, you got a good reason to why it's left and right? Very good. That's the way the parabolas are going. 1, 2, 3.6. Think of where your focus always goes. It goes on the inside of your parabolas. Your parabolas are hungry monsters, and they want that foci inside of them so that when they close, it eats it up. Or you remember foci goes in the middle. Everybody good there? All right, so when I label my foci here, we start with that center point, 0, 0. Which one of these two zeros, the x or the y, is going to get that plus or minus 3.6? Is it going to go with my x or with my y? Shania, why is it going to go with my x? So no, that's the way the parabolas go, and I went left and right to make my x's, so it's going to change my x-axis. So 0 plus or minus 3.4, 0, or 3.6, sorry. There we go. There's my foci. Lots of stuff there, but know that 90% of that was just me explaining. 10 minutes.